accept a story within minutes of it being delivered, the ones who are really, really effective, which is awesome for flow and for morale. I mean, what better feeling as a developer than you deliver a thing and 10 minutes later, the product manager essentially is thanking you for it. That feels pretty good, right? So there are lots of good things to having product managers in charge of acceptance, but this also means that we don't have to have a whole bunch of people who are doing this magical thing called acceptance testing and nobody actually knows what they do. It's the product manager's job. Usually that's manual, by the way, but we also test drive all the things. So teams as a whole own their quality, and as developers, our developers have a whole lot of very rigorous practices that come from extreme programming. We are unapologetically entirely an extreme programming shop with our own little spin on extreme programming, but pairing, test-driven development, continuous integration, all of the extreme programming practices are baked into our DNA as a company. In fact, it's kind of funny to watch people on teams that are odd for the day, because we never would send somebody home like, oh, don't come to work today, we're odd. Like we'd never do that. But then they have to solo, and they look uncomfortable sometimes. Like, I'm missing my and then you find this weird social thing happens, that the person who is soloing becomes the person who everybody goes to if they've got a question for the team, and it's almost as though they've lost their protective cover. They're now vulnerable because they're alone. So they will be circled, but anyway. So we pair fully automated regression tests. Part of doing test-driven development means that we automatically get a fully automated set of regression tests. Those run in CI all the time. So that means that we've checked all of the expectations before it even gets to the product manager. We know that it does all the things that we intended it to do as code. And because we've got 22 sub-teams and lots of those things have to come together to work as a cohesive system, we have entire pipelines. This particular GUI is from GoCD. We have now transitioned to using ThoughtWorks GoCD for an awful lot of our builds. It's not the only CI system we use, but if anybody wants to talk about GoCD later, this isn't really a talk about that, but that's what you're seeing is a screenshot of our build system. Okay, so we did all that stuff, and it was awesome, and that will get you a certain level of quality. And for that matter, I learned how to do extreme programming at Pivotal Labs. Chris talked about 2003. I met Ward Cunningham at Auta. I also met this guy, Rob Mee, and he's the guy who founded Pivotal Labs. And after that, I weaseled my way into one of his projects because I wanted to learn how this extreme programming thing worked. And then I was ruined for working anywhere else. So that's where I learned extreme programming. And my experience with working with Pivotal Labs teams was that I was the worst programmer on the team, probably the best explorer, but we didn't need anything that looked even remotely like traditional QA at all, and we were able to produce stuff that clients were thrilled with. Like, the quality was amazing, but you take something the size and complexity of Cloud Foundry, and now you try to apply that practice, and you can get close. But there's still going to be risks. There's still going to be things that are emergent behaviors because it's a massively distributed system, things that you only experience under certain circumstances. So that still wasn't enough, even doing all those practices. So then what do we do? Well, that's why I'm here, to talk about the exploratory testing piece and how we use exploratory testing. We capture stuff that we know that we want to explore in a charter. We put the charter in a backlog. That charter in the backlog, the PM prioritizes that like any other story. The deliverable for that charter is information. And so the PM has to weigh in their minds, would I rather have the team deliver a feature, or would I rather have information about this potential risk that we have identified? And you might think that a product manager would always be saying, oh, feature, 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 feature. But remember, the team owns the quality. So the product manager has no incentive to do feature, 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 because if their stuff doesn't work, there's no other place for that message to come back to than the team. So they'll end up doing a whole lot of rework later with pissed off customers. If we're going to do a whole lot of rework, we'd rather do the rework without pissed off customers. So they actually do have an incentive to prioritize the bugs. We also put bugs in the same backlog. So they have an incentive to prioritize their bugs and their charters all in the same backlog, and to actually put charters and bugs near the top frequently. In fact, usually bugs go straight to the top for the most part. So we capture these things as charters, and we'll talk more about charters. Anybody can add charters to the icebox. So let's say that you and your pair are working away and you realize, oh snacks. If this thing does this other, if the flubits does the whatsits to the nurbits, then really, really bad things are probably going to happen, but we're not sure. But this is not on mission for the story that you're implementing. Then you'd go into the into the tracker for the project, and you'd write a charter that then the product manager is going to be able to prioritize. PMs prioritize, and they accept those charters just as they would any other story, but the deliverable is a piece of information, so they have to believe that the questions have been answered. So that the criteria, rather than being a feature that you can actually see, is usually questions that we wanted that exploratory charter sessions to answer. And any pair is going to be able to pick up any charter. Yeah, question. Sorry? Wait, why are you ducking now just because somebody's trying to hand you a microphone?
Do you have any examples of questions that are charters?
I do have examples of charters. They're coming up. So let me just do the last bullet point on dedicated explorers, sometimes augment the team, and on we go. A charter follows the form of explore with to discover. It's like the story form of as a blank, I want blank because, which is to say it's a template that's useful but not necessary in all cases. And let's take a look at an example of that. One might be to explore possibilities. So in this case, explore deploying jobs in parallel with CF release to discover an ideal order of jobs to enable the least amount of serial jobs as possible. The whole point of this particular chart, I pulled all of these out of our backlogs, by the way, in case you're wondering why is there so much jargon in here. It's because I wanted real examples. This particular example is because our deploy times are really, really long. And it turns out that if you deploy the jobs in a particular order, then you can get massive parallelization along for some of them, and that's going to shorten the deploy time. And so the idea here is let's just explore the order of the jobs for the deployment to see if we can reach an optimal. So let's explore some possibilities. Other kinds of explore for possibilities things might be almost using an exploratory charter like you would a spike, because basically a charter can be like essentially like a spike. Another example, explore intermittent issues. How many of you have ever had an intermittent bug? Drove you nuts, right? Like, you know it happens because there have been multiple witnesses. They're credible witnesses. In fact, maybe you were one of the witnesses. This thing exists, but for the life of you, you cannot pin down the variables that affect its behavior. So if you could identify every single variable that affects its behavior and you could control every single variable, then there would be no such thing as an intermittent bug. You would just identify, control, and then bam, reproduce the thing, right? But you haven't identified all the variables yet. So this is where charters are really come in handy. You can brainstorm a list of variables that could affect the behavior of the thing, and then you could start tweaking how you interact with the software or tweaking the load or whatever it is that you're tweaking in order to reproduce the issue. So in this case, this one is explore large pools of executors running at the same time to discover bad behavior related to race conditions or flaws in claiming runs, being reasonable values of large. And so this was they added some specificity so that we didn't have just the word large sitting there. This particular charter came out of one of our components in the guts of Cloud Foundry. It's actually the next generation of the component. It's called Diego, and its mission in life is to execute your application. And so you've deployed your application to Cloud Foundry, and Diego has a whole bunch of VMs. Each VM has a whole bunch of containers. Your instances of your application are running in containers. And because it's doing things like saying, okay, now I need to run a new instance of this application, and different nodes within that cluster of executors are vying for the right to run that instance. They're bidding against each other. There's the possibility of race conditions. And so here we've got a charter that's all about exploring to discover the conditions under which bad race conditions could happen. Make sense? Yes.
Sure. What's the average number of developers per PM in this case?
So our team, our ideal is 1 PM, a set of developers, 2 to 3 pairs is where our sweet spot is. They have one backlog and 1 set of repos. That's our ideal. Sometimes we vary that depending on the circumstances. Sometimes we'll have a PM that works with 2 different teams, but our team size is 2 to 3 pairs typically.
Here's another question from one of our remote viewers. Can you articulate how a charter is different from a technical spike?
Sure. A technical spike is an instance of a charter, but charters aren't always technical spikes.
Okay, and one more. Are charters time boxed at all? How do you budget for charters in a team velocity?
Okay. So as a matter of practice, by the way, at this point I'm going to give up on the slides because there weren't that many more that were interesting, and all of your questions would be answered later, so then I'd go through the slides and I'd be like, oh, we talked about this. Oh, we talked about this. That's boring. So let's just do a conversation. That's way more interesting. There's an example. Yay. Oh, and I sent the slides beforehand, so presumably you'll have access to them if you actually cared about every single written word in there. Not nearly as interesting as talking about this stuff. So how do we budget for charters and do we time box? There are, for the way that we practice this, we typically do not time box, but sometimes a PM will say, it is only worth 4 hours of the a pair's time to me to get the answer to this question. So do whatever you can do in 4 hours, give me whatever information results. Don't go over budget on this one because it's just not worth it to me. But if the answer is really, really important and the time isn't going to be the thing that we're going to cut short. There is an entire school of thought around session-based exploratory testing. It's a thing, like you can Google session-based